Hello, I am Hemant Gehlot. I am a faculty member in the Department of Civil Engineering at IIT Kanpur. I am offering this course Transportation Network Analysis. This course aims to provide foundations for analyzing large scale transportation networks. Transportation networks are useful for transporting people, goods, and services from one place to another. A lot of interesting problems arise in the real world related to transportation networks. For example, the simplest problem that everyone would have encountered is called the shortest path problem. Here, the problem is to find the path that offers the shortest length between a two set of places. This problem becomes complex or non-trivial when there are a large number of paths between the two places and the paths might be very overlapping. So, in that situation, finding the shortest path might not be an easy task. Another interesting problem that arises in the real world related to transportation networks is called the traveling salesman problem. The problem is that if a person is standing at a current place and he has to visit a given set of places, then in which sequence should he visit those places and come back to his current place so that he visits all of them in the shortest time? This problem has applications in the logistics because a person might be having a set of goods with him and he might need to transport them to different places. So the objective might be how should he choose his path so that he comes back to his current place in the shortest time. This problem becomes complex when there are a large number of places that need to be visited. Another interesting problem that arises in the real world related to transportation networks is called the traffic assignment problem. The problem tries to understand how do different travelers divide themselves out among different paths when they travel. The naive solution to this problem might be that maybe everyone should travel through the path that offers the shortest length. However, if everyone does that, then that path might become congested and it might no longer be the shortest travel time path. And therefore, in that situation, it might be best that some of the travelers shift to another path. So, this traffic assignment problem tries to understand how do people distribute themselves across different paths so that a stable situation is reached. All of these problems, like the shortest path, traveling solution problem, and the traffic assignment that are discussed, are examples of optimization problems as there is some associated objective function with them. For example, for the shortest path problem, the objective was to find the path that offered the shortest length. Therefore, in this course, we'll be covering the basics of optimization first. So, we'll be going through a lot of optimization problems of well known problems. We'll be seeing how to mathematically formulate a physical problem, and we'll be also covering some of the basic categories of optimization. For example, we'll be going through linear programming, then we'll be going through integer programming and see some of the efficient algorithms to solve those problems. For example, branch and bound. We'll be also covering convex optimization, and we'll be understanding the basics of KKT conditions and how they are useful to solve convex optimization problems. So once we cover all of these basics of optimization, we'll be ready to tackle the problems that I mentioned in the beginning. So at the end of this course, the participants can expect that they'll be having the foundations for optimization and they'll be able to tackle these real world problems that arise in transportation and related areas. I look forward you to join this course, and if you have any query, please feel free to email me. Thank you.